Hello students, this is first lecture of chapter number 15 of your D-3 book, Geometrical Properties of Circles. So start this lecture from the first property of a circle, which is called circle symmetric property number 1. So the statement is, if a line L passes through the center of a circle and is perpendicular to the chord AB of a circle, then the line L bisects the chord AB. Okay, let me explain with some diagram. So suppose we have a circle just like this, and this is the center of the circle, and suppose this is point O. So if I take a chord AB on this circle, like this chord AB, then if I draw a perpendicular from this center to the line AB or to the chord AB, it will bisect the chord AB, just like this. This is perpendicular line that starts from the center O and it ends at the chord AB. I'm showing this. This is perpendicular line. Then this perpendicular line bisects this chord. Bisects means it will divide this chord in two equal parts. Say this is point C. So it means if it bisects, then it means AC line is equal to BC. So this is our property number 1, and it can also be said that if a line L passes through the center, conversely, if I say if a line L passes through the center of the circle and bisects a chord of the circle, then the line L is perpendicular to the AB. Like if a line passes through the center of the circle and it it bisects the chord AB, then it must be a perpendicular line. And the same property can also be shown by this third statement. If a line L bisects the chord, this line L, this line is L actually, bisects the chord AB of circle and is perpendicular to the chord AB, then it must start from center or it must passes through the center of the circle. So the same property can be said with three different statements. Statement number 1, if L is perpendicular to the chord, then it bisects chord AB. Number 2, if L line bisects the chord, then it must start from the center of the chord, or it is actually perpendicular to the chord. Number 3, if L bisects the chord, then it must start from the center O, or it passes the center of the circle. So we will apply this property in the questions of exercise 15A later. All right. The next property is symmetric property number 2. It says equal chords of a circle are equidistant from the center of the circle. So suppose we have a circle just like this. And say this is the center of the circle O. Then the property says equal chords of a circle. Equal chords mean if I draw two equal chords on this circle, first one is this, and the second one is this. Then these two equal chords, say this is AB and this chord is CD. Then these two equal chords will be equidistant from the center of the circle. So if I draw the perpendicular line from O to the CD and then O to AB, then, and these points are like, this point is X and this point is Y, then XO or YO are equal. YO is equal to XO. So this is the property number 2. Two equal chords will be equidistant from the center. This property can also be explained by the second statement. Chords that are equidistant from the center of a circle are equal. So if we have two chords and they are equidistant mean equal distance from O, then these two chords must be equal in length. All right, so this is property number 2. So moving towards exercise 13A, and we will apply these two properties in the questions. So question number 1 says, given that O is the center of each of the following circles, and find the values of unknowns. So in part A, we can see that the unknown is A and B. So we have to find their values. So we're looking for A first. You can see that this length is 5 centimeter from it, this 5 centimeter. So this is a right angle triangle. How did I know that this is a right angle triangle? Because we know that this line bisects this chord. As this line, as this side is A, similarly this side is A, so it means this line is bisecting this chord. So it must be perpendicular to the chord according to the property number 1. So I can write here, if this point is X and this point is OA and this is B, then I can write here angle OXA equals 90 degree. And applying property number 1. So if this is a right angle triangle AOX or AXO, then we can find the third side A by using Pythagoras theorem. So I'm applying Pythagoras theorem, applying Pythagoras theorem on triangle OXA. This is actually a right angle triangle. So here hypotenuse is 13. So I'm writing hypotenuse square is equal to square of other two sides and their sum. So OX is 5 centimeters. So 5 square, and the side which is unknown is small a. So A square. All right, shift this 5 square towards left hand side. The equation becomes 13 square minus 5 square equal to A square. So taking square root of both sides, so we're left with A square and A square root cancelled. So we're left with A is equal to 13 square 116 minus 25 144. So 144 square will be 12 centimeter. You can use calculator to calculate this, or man you can also calculate it manually. So A is equal to 12 centimeter. All right, B is actually an angle which is on triangle XOB or OXB. And in this triangle, we can see that two sides are known or three sides are known. So we can apply any trigonometric ratio to find this angle. It's actually a right angle triangle. I'm drawing here. This is right angle triangle. This point is X, B, and this one is O. And we are going to find this angle B. And the sides are, we have calculated this A, which is 12. This hypotenuse is actually the radius of the circle, which must be 13 centimeter. And this side is 5. So basically, according to this angle, if we see this angle, this the side opposite to angle is 12 and adjacent side is 5, and hypotenuse is a side opposite to the 90-degree, which is 13. So we can apply any trigonometric ratio to calculate this angle. So I'm applying here tan. So tan angle is B. Tan angle B will be equal to opposite over adjacent side. So opposite to this angle is 12. You can see this. This is 12. Over adjacent side is 5. So angle B will be equal to, I'm going to find this B by taking tangent inverse of both sides. So B will be equal to tangent inverse of 5. Tangent inverse of 12 over 5. So use your calculator to solve this. So B will be equal to 67.3801 degrees. And according to the Cambridge standard or exam standard, your answer, if the degree of accuracy is not specified in the question and the answer is not exact, then you must convert this answer or round it, you must round off this answer to one decimal place in case of angle. So answer will be 67.4 degrees. As you can see that the digit after the 3 is greater than 5. So 3 will become 4. So this is B. Okay. So moving towards the next question. Question number 1, the same question but part C. So in this question, two values are unknown, E and F. E is actually a side and F is an angle. So as you can see that this 10 mm is a chord. So and a line must bisect this chord, as this line is perpendicular to the chord. So it must bisect. So this will become 5 and this side will become 5 as well. So you can easily find F. But first of all, you must know the radius. So to calculate the radius, I'm drawing a line with the blue color. It starts from O and ends and this point. So this is actually a radius. Now you can see that this side must be 6. Why? Because this is a chord and a line perpendicular to this chord bisects this chord. So this will become 6, half of 12. So now you have a right angle triangle. You can find this value, the radius. This is R radius. So applying Pythagoras theorem on this triangle, R square means hypotenuse square is equal to 6 square plus 5 square. So R will become 6 square plus 5 square whole square root. So R is equal to, use your calculator again, 6 square plus 5 square. So you get square root of 61. I'm not solving it further because I will use this value in other part. All right. So R is 61 square root in millimeters. It means this side will be square root 61 as it is radius 2. So I'm going to find E by using Pythagoras theorem on this triangle. So the side opposite to 90-degree, which is hypotenuse, is 61 square root whole square, equal to other two sides are first one is E square, and the second one is 5. So 5 square. Okay, solving it, square and square root cancel, so it will become 61. Okay, shift this 5 square towards left hand side. So 61 square minus 5 square equals E square. Now taking square root of both sides. So E will become 6. So it means this side will become 6 centimeter. Now we can find this angle F, as this is actually a right angle triangle. This angle was F. This is 90-degree. And this is E, which is 6. We have just calculated. It is 5, and this radius is R, 61 square root. So I'm again applying a tangent. So tangent angle F will be equal to opposite over adjacent side. So opposite side will be 6 and adjacent is 5. So F will be equal to tangent inverse of 6 by 5. All right, solve it. Tangent inverse, use your calculator to find this inverse. 6 divided by 5. Tangent inverse gives you 50.194. Again, convert this angle to 1 decimal place. So answer is 50.2 degrees. So this is your final answer. So this is question number 3. A chord of length 24 meters at distance of 5 meter from the center of the circle. Find the radius of the circle. So going to draw the circle in order to make the question easier. So suppose this is a circle and this is center O. A chord of length 25 meters at center. Suppose this is the chord I'm drawing here. And its distance is at a distance of 5 meters from the center of the circle. So this is actually the perpendicular line that intersects a chord, and its distance is 5 centimeter. So I'm writing here, this is 5 meter, not centimeter, meters. And this chord, total chord is 24 meter. This one. So as it bisects the chord, so this length will become 12 meter, and this one is 12 meter as well. So find the radius of the circle. The radius is this. Say this is R, the radius. So we have to find the radius. As we have a right angle triangle in which two sides are known, 12 and 5. and third side can be calculated by using the Pythagoras theorem. So right here, applying Pythagoras theorem, so it says hypotenuse square, which is side opposite to 90 degree, and you can see that it is r square is equal to sum of square of other two sides. So 12 square plus 5 square. So taking square root of both sides, so r will become 144. 12 square is 144 plus 25, 169. And square root of 169 is 13 centimeter. 13 meters. It was good because units is in meter. So this is the value of r. Okay, move towards next question. Question number 5. Given that O is the center of each of the following circles, find the values of the unknowns. So the chord at the left hand side has a length 22 centimeter and it bisects by a line this that starts from O. So it means this will become 11 and this will become 11 as well in centimeters. And similarly, these two lines, this equal length, so it will be x as well. So from the first property, we know that if the line intersects a chord, then the line must be perpendicular to the chord. So it means this y will be 90 degree. Y is 90 degree according to the first property. So how to find x? I'm drawing a line that starts from O and it ends at the one corner of the chord. So this is actually a radius of the circle. So radius of the circle must be known in order to calculate this x. All right, we can apply the second property here. According to second property, if the chords are equal, then they are equidistant from the center, and we can see that both of the chords are equidistant from the center, as these two cuts showing that these two lengths are equal. So it means these two chords must be equal in length. So it means this length will become 22, equal to the first chord at the left hand side. So x will be equal to half of 22, as x is actually bisector of the chord. So x will be 22 divided by 2 equal to 11 centimeter. So x will be equal to 11 centimeter. So we have calculate the values of both x and y in this question.